Welcome to the second video of a series of 8 on polar graphing, multiple representations. Before we can get to the actual graphing of polar equations, which starts in our next video, video 3, we have to talk about what multiple representations means in terms of polar coordinates. Multiple representations is a phrase that refers to the fact that one point in the polar plane can be represented many ways using different r's and thetas. And to give you one example and a general sense of what I mean by that, let's just pick a point in the polar plane right here. You'll see the dot that appeared, and this red dot, it turns out, even though it's a single point, it can be represented many ways using polar coordinates. Well, you'll recall that polar coordinates are coordinates that refer to a point's distance from the origin, which we call r, and standard angle, which we call theta. So, what is the angle at which this point lies? Well, as you can see here, I've chosen a point that lies at a 60-degree standard angle, or pi over 3 in radians. I've also chosen a point, just as my example, that is 6 spaces away from the origin. If you count the concentric circles from the center out, you'll see that this red dot is 6 spaces away from the origin. In other words, this distance here is 6. And as such, we in polar coordinates call this 6 pi over 3, again referring to a distance and an angle. So this single point here, we just showed could be referred to as 6 pi over 3. Nothing too difficult about that, hopefully. But let's look at other ways we could represent this point. This angle here, which we just called pi over 3, we could represent it as a much larger angle. Imagine we were to go a full revolution around the circle, or 2 pi, and then to continue or keep going an additional pi over 3. 2 pi plus pi over 3 simplifies to 7 pi over 3. And to use language from previous videos, 7 pi over 3 is coterminal with pi over 3. This distance is still 6, and therefore we could refer to this point as 6, 7 pi over 3 as well. So far we've looked at 2 different ways we could name this point. Now one might think that I've really just named it the same way. But let me remind you, even though pi over 3 and 7 pi over 3 are coterminal, they're definitely not the same number. Pi over 3 on a calculator works out to about 1.05. 7 pi over 3 works out to about 7.33. They're definitely different numbers, and therefore these two things count as different representations. But they're not the only 2 ways to represent them. What if we were to represent this angle in a different way, other than pi over 3 or 7 pi over 3, by going clockwise? You'll recall that clockwise angles are negative angles. And if we work out the math and figure this out in reverse, it turns out to be negative 300 degrees, also known as negative 5 pi over 3. And again, being 6 spaces away from the origin, I could refer to this point as 6, negative 5 pi over 3. And now that I've referred to this point in 3 ways, one quickly realizes that there's no limit to how many different ways that I could name this point using 6 as my r value, or my distance from the origin. But here's something else to consider. Those who invented polar coordinates centuries ago wanted to allow for negative r values. They wanted to be able to call this a distance of -6. Now, of course, there's not really such a thing as a distance of -6, but they wanted to refer to negative r values to make the whole system complete. So here's an idea that they had centuries ago I'm going to share with you now. They decided that the, quote, distance from the origin could be considered negative as long as the angle, the theta value, was facing in the opposite direction of the point. Notice the purple dotted line. So if I can figure out this angle here, which by the way works out to be 240 degrees, also known as 4 pi over 3, then I could name this point with a negative r value. Again, as long as my theta value faces in the opposite direction of where the point is. So now I have 4 different names for this point, and I'll create one more just to give you the broader sense of what's going on. What if I wanted to use a negative r value again? Couldn't I refer to this angle as something other than 4 pi over 3? Yes, of course, there are infinitely many things coterminal with the purple dotted line. And so, if I wanted to, I could refer to that angle as a clockwise or negative angle as well, which would be negative 120 degrees, also known as negative 2 pi over 3, thus giving it yet another name for this point. And so the purpose of this video is to convince you that there are infinitely many different ways to label one particular point. All of the ordered pairs you see near the top of the screen are all referring to this red dot here. And that completes the second of 8 videos.